Sometimes, especially when we're working with large numbers, we aren't really interested in the exact value of the number. We just want an estimate. Sometimes, for example, we don't really care that the number of spiders that we have crawling all over us is 49,203,874,026 spiders. Sometimes it is enough to know that we have about 49 billion spiders crawling on us, and maybe we should consider not going spelunking again. So this process of going from this super specific number that takes a really long time to say to this slightly less specific number that doesn't give us the exact number of spiders, but is easy to say and is close enough. This process of going from the specific number to the estimate is a technique called rounding. In this case, because we chose to end up with just some number of billions, that is, our last non-zero digit is in the billions place, units, thousands, millions, billions, 1 billion, 10 billion, 100 billion. Our last non-zero digit is in the 1 billions place. We say that we've rounded to the nearest billion. Why do we say that? In particular, why do we use this word nearest? Well, recall that the billions are the numbers that we're going to get when we skip count by 1 billion. So 1 billion, 2 billion, 3 billion, blah, 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 etc., etc. Eventually we're going to say 49 billion, and then what'll come after 49 billion? Right, 50 billion. Why are we interested in these two numbers? Well, remembering what we know about comparing large numbers, this number, 49,203,874,026, is going to be between these two numbers. If we want to round to the nearest billion, right, what does nearest mean? Just what it means in English. Nearest means closest. We want to know which of these billions this number is closer to. Okay, let's think about some smaller numbers for a minute, shall we? Let's suppose we just wanted to round 492 to the nearest 10. Right, 492, that's going to be between 490 and 500. Right, these are the two numbers that we would say, skip counting by 10, that 492 is going to come in between. Which one is 492 going to be closer to? Let's just look at it on a number line. Here's 492. Here's the distance between 492 and 490. Here's the distance between 492 and 500. Which one's bigger? Obviously this one. So, because this is the smaller distance, 492 is closer to 490. We'll round 492 down to 490. Now, we certainly don't want to draw this picture every time, right? But that's okay. We can kind of generalize this idea, right? Looking at this picture, 495 is right in the middle, right? The distance is 5 this way. It's 5 this way. 495 is the same distance from 490 as it is from 500. That means any number that's smaller than 495 is going to be closer to 490. Any number that's bigger than 495 is going to be closer to 500. What should we do with 495? Well, let's think just a little bit more about that. Let's say we weren't rounding to the nearest 10. Let's suppose we were rounding to the nearest 100. And now when I'm marking my number line, I'm not going to mark every number. I'm just going to mark the tens. Notice that these two number lines look very, very similar, just the scale is different. Up here, every step represents 1. Down here, every step represents 10 units. But just as 495 was in the middle up here, 4,950 is in the middle down here. 10, 20, 30, 40, 50 units this way. 10, 20, 30, 40, 50 units this way. And the number we're interested in, 4,953, well, that's just a little bit more than 4,950. So it's on this side of 4,950. We want to round it to 5,000. And notice that this 3 didn't really matter to us, right? As long as there's some non-zero digit here, our number is going to be just a little bit this side of 4,950. 4,950 something is something we're going to round up. All right, I think we understand now how we can tell by looking which of the two values on either side our number is closer to. How do we do it? Well, here we're rounding to the nearest 100, so we come up with the two hundreds on either side. And then we look at the digit to the right of the hundreds place. That's going to tell us where on this number line our number appears. If this digit is 5 or more, we're going to be closer to 5,000. If this digit is smaller than 5, we're going to be closer to 4,900. Oh, if this digit is 5 and then it's all zeros afterwards, we're right in the middle. But you know, how often is that going to happen? We're just going to ignore all the digits after the tens place, and we'll make a rule that says if by chance we happen to get that number right in the middle, we're going to round it up too. The reason that we make that rule is that it means that we never have to look at any digits after the one after the place we're rounding to. So when we were rounding the number of spiders, we were rounding to the nearest billion. This digit in the next place is a 2, which tells us that this number is closer to 49 billion than it is to 50 billion. So when we rounded to the nearest billion, we discovered that we have about 49 billion spiders crawling all over us. That seems kind of complicated. Let's write down what those rules are. So if we want to round to a given place, of course our first step is to actually know what that place is. So we need to locate the given place. Once we've found it, we should either write down or think about the two numbers skip counting at that place on either side of our number. Then we want to decide which one of those two numbers our number is closer to. How are we going to do that? We're going to do that by looking only at the next digit. If that digit to the right of the given place is 0, 1, 2, 3, or 4, we will do what's called rounding down. That is, we'll choose the option that's less than the given number. If that digit is 5, 6, 7, 8, or 9, we round up. We choose the option that's more than the given number. Right, remember, if that next digit is 5, our given number is probably closer to the bigger number. Maybe it's exactly in the middle. but we'll just make our rule that if it happens to be exactly in the middle, we'll round up anyway. Let's do a couple of examples together. Let's round 48,125 to the nearest hundred. So our first task is going to be to locate the hundreds place. So in the units group, ones, tens, hundreds. So as we skip count by 100, 100, 200, 300, blah, 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 48,100, and then 48,200. Our number, 48,125, will be between these two numbers. How do we decide which one it's closer to? We look at this next digit, which happens to be a 2. 2 is one of these digits, 0, 1, 2, 3, or 4. And if we drew a number line, this number would be located closer to this one than it is to this one. We round to 48,100. I'm going to give you one of these to try. Round 207,562,998 to the nearest 10 million. Pause the video and try this now. Alright, so our first task again is to locate the 10 millions place. So units, thousands, millions. And within the millions group, 1 million, 10 million, 100 million. So here is the 10 millions place. As we skip count by 10 millions, we'll have what? 190 million, then 200 million, then 210 million. Our number, 207 million, blah, 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 etc., is between these two numbers. We didn't really need that 190 million. It was just to help get ourselves situated. Our number is between these two numbers. We need to decide which one it's closer to. To decide that, we'll look at this next digit. It's a 7. 7 is one of these big digits, 5, 6, 7, 8, or 9. That tells us that this number is closer to 210 million.